Hello, everyone. Welcome back from lunch. Thank you all for joining us for our second session of Symposium. Our second theme is human-machine teaming. We're glad to have you back here again this afternoon for more interaction, more conversation around these topics. My name is Christine Brew. I'm one of NC State's technical program managers with the Laboratory for Analytic Sciences, and together with my government co-lead, Tim Smith, we are presenting the human-machine teaming thematic area. As with the morning session, the session will begin with some introductory remarks before we will welcome our 2024 collaborators on stage to give a series of lightning talks on each of the projects in this area. After the lightning talks, we'll head back next door where we'll have our hour-long interactive session, posters, demos, all of that good stuff. So considering human-machine teaming, at the lab, we take a broad understanding of human-machine teaming, considering all integrated systems involving human-machine interaction. In taking this integrated approach, a successful outcome occurs with an effective partnership between the two. So good performance is not just good model performance, but the ability of a human analyst to understand, interpret, and apply the knowledge generated from a machine or an AI partner. Advancements in new technologies and modeling are important for improving performance, but for the team to be successful, a human analyst needs to be able to apply these performance gains to their work in a meaningful way. In our other two sessions, you'll hear a lot about these advancements in operationalizing AI/ML and content triage to support our analysts. In this session, we focus specifically on the connection between the human analyst, their capabilities, and how to best use novel technology to support them in the complex meaning-making work that we know humans are best at performing. There are three important themes that link together the projects in this area: user-centered design, users' cognitive factors, and techniques for the communication and visualization of complex data. In our projects, you will often see these three concepts closely linked together, oftentimes multiple represented within one project, but I'd like to take a moment to introduce each of these three concepts separately. User-centered design is, as it sounds, designing with the user in mind. Sounds easy, but in practice, this is a very nuanced process, often involving multiple rounds of user feedback and revision as new design options are developed. Though this is more intensive, a successful result of this process is a new tool that is tailored and responsive to the needs of users. This becomes particularly important when AI is integrated into tools and as tools seek to build trust through explainable AI. By partnering explainable AI with effective user experience design, we can enable users to better understand, trust, and have more productive interactions with AI systems. Users' cognitive factors describes all of the complex processes that are unfolding as a user engages in analytic work. By understanding an individual's approach to data and complex tasks, we can understand the cognitive factors that are at play as individuals respond and make decisions based on data or tools. Avoiding cognitive biases and cognitive overload are key to avoiding errors and increasing efficiency in the process. Projects examining cognitive factors often also touch on the all-important factor of trust, addressing how we can help users understand when to trust system outputs or when the system is limited in the guidance it can provide. And finally, techniques for communication and visualization of complex data. These underlie many of the tools and visualizations presented to users, so accuracy and reliability of these underlying models is important for the strength of the complete system. Addressing how we can help users, going from the data to outputs to a user who needs to make sense of it all and draw conclusions. Within this set of lightning talks, you'll hear about projects on knowledge graphs and named entity recognition, describing how they can help users interpret complex data, making it more digestible and also able to be visualized for the user. By taking a human-centered design approach, understanding cognitive factors as a part of effective analysis, and leveraging techniques to communicate and visualize complex data, we can develop systems that are responsive to analysts' needs and the challenges that they face day to day. And now I would like to welcome our collaborators to line up to the right side of the stage here so that we can begin our lightning talks.